My dear friends, we have seen in session 3 the rules of plug setting of phase relays. That is the relays which operate for LL and triple line fault. We have yet to see the time setting. So this video is going to be too short. Probably only 15 or 20 minutes, because the upcoming videos are going to be larger. So it is not possible to, because if I incorporate that, then this would be 45 minutes or an hour. I do not want that my friends are tired of hearing the video for an hour, for 15 minutes, 20 minutes, half an hour, or at the most 45 minutes. It's okay. You can hear. So here we will see the rules of time setting of relay. Now it's very clear that the last relay R3 should operate first. But R2 should not operate after an hour or after a day or after 100 years. I mean, it is also time delay, but it is not so. It has to also operate as fast as possible. So what is that fast? That we have to see. So that will show in terms of figure. Say on x-axis there is current, on y-axis there is time. And I have to consider the maximum current which concerns two relays. Say here R2 and R3. You will agree that R2 operates first, R2 must operate first, and R3 must operate afterwards. So R2 operates after time A, that is OA is the ordinate. And AF is discrimination margin. AF is known as discrimination margin. So how have we to calculate that discrimination margin? That is very important. So first is AB. What is AB? You see, relay manufacturer is manufacturing 100 relays a day. So he cannot say that all relays will operate within time OA. There has to be some time tolerance. Time tolerance given by IS is up to PSM2, no time tolerance. Relay must operate. That is the only. From 2 to 4, PSM 2 to 4, plus or minus 12.5%. And for PSM beyond 4 to 20, because after 20 it is definite time. So 4 to 20 it is plus or minus 7.5. So we take it for granted that this is first current is in the range beyond PSM 4. So we take 7.5% error. So relay R3 should operate within time OA, but because it may be slow by 7.5%. So AB is minus 7.5% I have taken. So if you set R3 as 0.1 minus 7.5%, that is 0.1 into 0.075. Time is very small, but that time is there. AB is the relay error of relay R2. It can be fast also, but then I'm not worried. If it is fast, I'm not worried. This is the worst case, right? Similarly, relay R2 also has time error, right? It has plus 7.5%. It operates faster. I mean, that is the worst case. So EF is the time error of R3. Now, you see, after time OB, R2 has operated. R2 has operated does not mean that fault is cleared. Fault is not cleared by relay. Relay gives signal to breaker and breaker operates. No doubt nowadays 1 cycle, 2 cycle breakers are available. So BC's breaker time. BC's breaker time I have considered 2 cycles, 0.04 seconds. You can see, right? And so at time C, the relay R2 has stripped the faulty section. But now try to understand that if it is an electromagnetic relay, it keeps on rotating. Because it was rotating at very fast speed, it keeps on rotating even if the current is discontinued for some time. Then it will come back to its original position. That some time is known as overshoot or over travel in terms of time. And try to understand that it is not true for electromagnetic relays. It is true for static relays also. In static relays, there are inductive circuits, and inductance does not die down the current within no time. No doubt, in electromagnetic relays, the overshoot is 5 cycles. In static relays and numerical relays, it is 1 cycle, but overshoot is there. So that DE is overshoot. Now you try to understand. I've come up to C and I've come up to D. If C and D coincide, then R2 and R3 both will operate simultaneously, which is wrong because the fault was beyond R3. Therefore, you have to consider relay errors, breaker time, overshoot, and then you have to consider safety margin CD, which I have considered 0.1 second. So considering all this, I am considering AF as 0.25 second. No doubt many papers, the journal papers in IEEE and many other things. Some people are taking 0.2 also. Some people are taking 0.15 also. I mean, it is a discriminated thing. Some relay manufacturer says that my error is not 7.5%. My error is just 2.5%. Some breaker manufacturer says that my breaker does not trip in 2 cycles. It trips in 1 cycle. You see. Somebody says that my overshoot is not 1 cycle, my overshoot is hardly half a cycle, practically nil. So AF can be reduced if you have better relays, better breakers and everything. But we will consider 0.25 second AF. That means once the relay R2 operates, I will make the time of operation of R. So once relay R3 operates, I make the time of relation of R2 after 0.25 second. No doubt, once R3 operates, R2 has not to operate, so no problem. But if R3 fails, then after 0.25 second, R2 will operate. So this is the time setting methodology for the time tolerance I told you, so I don't repeat. Yes, time setting, how have I arrived at 0.25 second? That I've tried to calculate that you can read all these things that I've done. How have I arrived at 0.25 second? That I've talked. And with that, this IDMT relay, how to set is over. How to setting is very critical. You see, if you make a mistake in setting, the equipment will be damaged, or probably you will trip very early. So unnecessarily you are tripping early. So relay setting is very critical, and therefore power system protection is a very important subject. Many universities who had this subject in 7th semester, they brought in 6th, because in 7th uh, the interviews, that is the campus interviews, are coming. So at that time they should know this subject. So out of all 40 subjects, if I mistake not, probably 50% weightage goes to power system protection. So please, I would again and again request you that this videos of ADAPME should reach to each and every engineer in the world, each and every electrical engineer, obviously, who is interested in power system protection. Somebody is interested in power electronics. I am not worried. He may not see. Somebody is interested in microprocessors. He may not see. I don't mind. But those who are interested in power system and power system protection, all, not a single should be left. Everybody should have seen, and everybody will see only if you send to them. I am helpless. I do not know many. So this video is reaching to 100 people or 1,000 people. Those 1,000 people, if those another 100 people, so then it will go to 1 lakh people. And if those 1 lakh people know another 100 people, it will go to 100 lakh people, 1 million people. Like that, the video will reach to 10 million electrical engineers free of cost. And if you know, then also just go through what I've written. And if I've done any mistake, you can tell me also, because usually I'm writing my telephone numbers. Probably in this slide, I have not written my telephone numbers. But if you want to note down, my email ID is Oza Bhuvanesh, OZA Bhuvanesh. I repeat, OZABHUVANESH @gmail.com. I repeat, OZABHUVANESH all small, no spacing. You are most welcome to many people have reached me. I don't know, probably have written also the my telephone number in this slide also. So please contact me if I'm wrong. You are because I am not the master. There are many people who are much better than me in protection. They can always correct me. I will welcome them. Till then, thank you, my dear friends, and good day.